Okay, welcome to the NUPOC video study guide number 34. Let's look at question 9 in the graphing math section of guide 1, where we have this quadratic function, and in addition to graphing it, we're asked to find the minima within these boundaries of x. So let's go ahead and start by finding the roots here. So this is easy enough to do by inspection. This is just going to be what multiplies to minus 6 and adds to positive 1. A couple of factors of 6 are 2 and 3, so it looks like we would probably go with plus 3 minus 2, right? Okay, so now we have that, so we know we have roots at x equals minus 3, x equals plus 2. So let's put these on the graph here. So let's say it's about x equals 2, and this is about x equals minus 3. Okay. So now let's look for any critical points. So we'll take dy dx equals 2x plus 1. We set that equal to 0. We'll get x equals minus 1/2, which is actually halfway between these two roots. Okay. And now to find whether it's a minima or a maxima, let's go ahead and evaluate dy dx to either side of that critical point. So first we'll evaluate at x equals minus 1, and we will get minus 2 plus 1 equals minus 1, right? So we've got a negative slope to this side of the critical point. Let's go ahead and put the critical point on here, right? So that's x equals minus 1/2. And we'll evaluate dy dx, evaluated at x equals, let's say 0, to the right of that critical point. So that just is 0, 0 plus 1 equals 1. Okay, so we have the same slope but opposite sign, so we're climbing to the other side, to the right side of the critical point. So if we're coming down here and then going back up, that is a minima. Alright? And again, this is a second order polynomial, so we expect it to have some sort of, and we have a positive sign right here on the square term, so we expect it to be concave upright. And just to test that, of course, if we took d2y dx squared, right, we're just going to get 2, right, which indicates that we have constant upward curvature. At all times, the slope is increasing. Right here it's negative and it's getting less negative, passes through 0 and becomes more and more positive. Right, so we're concave up as we expected. So let's go ahead and evaluate the function at that critical point. Right, so that's just minus 1/2 squared, so minus 1/2 times minus 1/2 plus minus 1/2, so minus 1/2, right, minus 6. Well, that just equals 1/4 minus 2/4 minus 6, right? So this is just minus 6 1/4, right? Minus 6 1/4. So let's just, the y-axis scale is going to be a little bit different than the x-axis scale. That's okay. This is y equals minus 6 1/4. So there's our critical point, and we go up from there through our root there, and up that way through our root on the other side. Alright, so that's our graph of the function, and we know that our minima, again because this is at x equals minus 1/2, so we're in these bounds here. So our minima is y equals minus 6 1/4 at x equals minus 1/2. Alright, so there we go. Just a quick solution for the graph and the minima within the bounds that the problem indicated.